Wait.
I thought that was 10 inches.
The loop will be 10 inches.
The
right?
rope can only be an inch.
Yeah.
Okay.
Yeah, you can have as many loops as you want, and you can have it up to
As long
10,
as the material is not more than 1 inch.
right, and 10 inches in the diameter of the loop. And this rope is 7 feet 8 inches. You're fine.
So for your feeding rollers that load up into the shooter, are they all continuously rolling?
Yes.
So what happens when the one on the left and the one on the right both have balls at the same time?
One of them would win.
One of them wins.
It just, the chance of that jamming is,
Okay.
yeah.
In your gear mechanism, is it open on the front? And if so, how do you keep the gear in place when you're driving, or is it closed on the front?
No,
And if
okay.
so, how do you release the gear when you're on the tank?
So over here you can see like these things, that's just metal on the front. And so when the gear would slide in from here, it would be held in place by these. And when you attach it, you just kind of drive forward onto the peg. And once it's forward, you would open it in the back of it.
Yeah.
Like that?
Slide like that. Yeah.
So in our design, we were discussing the point since there's 5 of these dividers between the outer ring and the inner ring. We're thinking about if those rings, if those dividers were like just hit right onto the rod, that would be a problem.
Which divider?
Like you know, the wheel, there's the outer ring and the inner ring that have those.
Oh,
those
okay.
rings.
Yeah.
If you don't have the rod, is this like if the work out really unlucky, you just hit right through like that and you don't hit on the rod and you can't do it.
The thing is, like, the spaces between each of these rocks is pretty big. So the chance that you're going to
And it's a spring.
Yeah.
So when we went to New Hampshire, we did try that. Basically what happens is no matter how you put the gear, the spring always sort of deflects into one of the holes.
Right.
Like it's kind of
Yeah.
hard to get it stuck. It's impossible to get it stuck on the gear. That was it.
No, I did that too. So, yeah, Jordan.
Given that the climber has to support almost maybe more than 140 pounds, how do you plan to make the pins so that they don't deform rather than
The hooks.
the hooks, and how far apart do you plan to put them on the roller?
The
Given that
thing with like the hooks is once you get one loop, it's not only supported by the hook anymore, it's supported by the entire system. And so,
no, but the hook might bend backwards. So if you're trying to because if the roller is the only thing that's touching the if the roller is if there's only one roller.
But once you get a couple of wraps around it, it's friction that's holding it, not the pin.
True, but if you have to get those first pins.
Some
Yeah,
of it
but there's no way.
material
No way.
selection could matter for that.
Use alien technology.
Or you could just have a little,
Yeah.
Jordan, you can also just have a little slack in the
Magnetic,
the first 3
non-metallic
rings.
rope.
You go around
Don't have to pull it out.
Let your
Yeah, guys.
let the design group answer. It's their design.
but yeah, that's like friction. So any more questions?
Anybody else?
Yeah.
So for your shooter, is it just feeding from 3 in the front, or is the shooter in the center of the hopper with it feeding from all around?
The shooter's at the it's at the front of the robot.
Okay, so
So it would be at the wall, and then the balls would all be funneled towards that one general direction.
so it has like 3 entries. Okay, it's not all the way around.
No, it's not. Yeah.
Nice.
Last but not least is number 2.
Save the best for last.
Yay! No, he said, what are we doing after this meeting? Go home. Tomorrow?
Didn't mention the
It's going to be another, again, 15 minutes, half an hour. Okay, they're ready. Great.
Good talk.
So, yeah.
So this is all the people in our group. We're not, we're the ones who are here, so sorry people who aren't here.
Alright, so our game strategy, what we really wanted to do was we really wanted to have all three main thingies. So we wanted to have, we wanted to do only high efficiency fuel. We wanted to collect gears, and we also wanted to climb. We also wanted to have really strong defense, and we wanted to be able to collect fuel from the floor and from the hoppers. So, in auto, we want to be able to shoot at least 10 balls while placing the gear at the same time. And we want to cross the baseline and get to the hopper if we have time. And then once we get to teleop, we'll be able to drive to the feeder station, get the gear, pick up the balls on the way while we're hitting the gear. And then we'll deliver the gear while shooting. And then chassis. So we looked at all of these things for all possible combinations, and we decided on short tank, mainly because we wanted to have the hopper. So that was a really big part of it. If we hit the lever, then we could get all of the balls from the hopper very easily. Also, we could have good defense because it's strong, and is not as strong with that. We'll be able to pick up the balls from the floor more easily, and it's a lot easier to build.
So for fuel collection, we thought we would have a, so for hoppers or the pickup stations, we would have a ramp. And so essentially what would happen is the balls would fall down and they would go to the top of our robot. They would go down a ramp, at which point there is almost like a chamber, if you will, where they would essentially be processed and sent in. From the ground, we would have a spinning axle intake, so it would be up against the robot, and then at the beginning of the match, when we wanted to pick up, we would drop it down. So there would be rollers just straight ahead, and then on the sides diagonally, there would be rollers going perpendicular to those to shoot it into those, and then from there they would come in. And again, it would be going into the same chamber cabin area, just from a lower angle. Yeah, and since the robot, we chose the short stout one, we'll be able to drive straight into a hopper, and without a lot of adjustment, we can collect the majority of the balls. And any that we forget, we can pick up on the way later with our drop down or at that exact moment. So, yeah.
Okay.
Can you see that?
No, it's
So,
invisible.
yeah, essentially that's what I was just talking about, so.
Get the marker.
Take the marker and go over it,
Outline
yeah.
it. Right there.
Okay, how about if you turn off the lights?
Oh no,
Everything broke, that's what happened.
What happened?
Alright, so if
So I
I
made
do
sure
one class, the
Benji,
one class I
Benji, like-
failed. So, here you have essentially, here's, from the robot, very, 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 very rough. So this would be a top view. So it folds up in here, and then when you drop it down, essentially would have,
Oh, there it is.
well,
There it is.
Yeah, turn off the lights.
so ignore this terrible art. It's not
I'm
existent.
gonna turn off the lights. That's right. And you just take them right back.
Okay.
Oh, nice job, Carl.
Go back. Go back. It's fine.
Okay,
Yeah, what are you doing?
No, you can see the, we want to see if you can see the picture in the dark.
Okay. So are we doing this or this?
Go back to the picture.
Right.
Confirmed that or on blue? Or,
Okay,
okay.
fine.
So I'm just gonna go over this real quick.
Is the top view? Yeah, that's top view.
Yes, this is the top view.
Draw the numbers,
Where are we?
like right here and.
Oh, yeah. Very rough.
There are gaps.
Yeah, so the gaps here are where the bumpers are. So this will drop down, as you can see the picture thing. So basically what happens is these rollers go down this way. And these rollers will then propel any balls from the sides caught by this or just head on into this version of the chamber here, which leads into our central hopper. So that's our ground pickup. And
Yes, we wanted to actually have the extension of the robot, because specifically otherwise it would be a dead spot where we just wouldn't pick any balls up through normal driving motion, and we predicted the field was going to be, yeah. We predict the field will have balls scattered everywhere, just because robots will typically not be able to cover both sections of the hopper at once when they're activated. So we think that if we just have this mechanism running while we're driving across the field in order to get gears, we'll be able to pick up a lot of balls in the way.
Okay. For climbing, Benji did some wonderful Googling and found retroreflective climbing mode. So, vision, strong rope, thin, magic. So, essentially, that intake I was talking about earlier, that whole thing that we just want to roll spiel about with the cord. So, the idea is we're going to feed the rope through that intake, lining up using vision. And so it's going to wrap around the intake bar, which is then going to act as our hoist to lift us up 90 degrees. Yeah.
Okay, so for gears, we decided that we were only going to do the feeder station for gears. We thought that gears typically wouldn't fall on the floor unless like a rookie or something messed up, and in that, or if robots were playing strong defense, and in that case, we determined that it wouldn't be worth having an additional mechanism on the robot to go and handle that situation. So the feeder station, so what will basically happen is within the same sort of slot that we're receiving balls to from the feeder station, there will be a little depression. And in that depression will be where gears feed in, such that it will match the thickness of the gears, so that gears will be able to come in sort of underneath into their own little sub-channel, or the balls pass over that slot, and are able to make it to the main chamber of the robot. Gears basically then just follow the channel through to the other side of the robot, where they basically drop into a vertical slot, sort of hockey puck style. And then we actually designed this around the concept that without knowing that you'd be able to lift the gear out of the robot, because we don't like to assume things about the rules that we don't know, because bad things happen when we teach things that do that. So we decided to have, at least in this initial design, 2 pneumatic flaps, which would basically hold the gear in place while we drive up to the spring and have the spring on the gear. We also determined that if the gear were to be aligned such that the spring would hit a solid base of the gear, the spring was reasonably springy enough to eventually go around that piece as we drove forward. So we decided not to worry about that. And then at that point, you'll be able to release your sort of holders on either side pneumatically and drive back, and then the gear will be on the lift. And the 2 retroreflective tape, strips of retroreflective tape on the side of the left would actually help allow for vision assistance should we decide otherwise. And that's, again, hard to see.
That's the slot for the gear.
But it's not too complicated of an idea. This is sort of a top view.
No, it's side.
That's top view.
No, that's a top view.
Oh. So as you can imagine, gear passes through and lines up in this vertical place.
What?
So basically, this right here.
Oh, no, go to the next page. Go to the next page.
Oh, that's the problem. This is what it looks like from the way of reasonable.
That's from the right side.
There's not a
eraser, right?
That's a lot of rollers.
So, the rollers are just okay, the rollers are hypothetical. Basically, there's a question of whether there would be too much friction within incline that gradual that would cause the gear to not continue moving. So, we decided that in that case, we could use passive rollers. Not necessarily that many, but passive rollers every so often to make sure that the gear keeps its momentum.
So you prefer this to a frozen slide?
Yes, we prefer this to a frozen slide.
Yes.
You can print their rollers.
Oh boy.
And that's what it looks like when it's in place. That's a gear.
There's a gear slot.
Okay.
So similar to others. So the big difference here is we would feed the gear in from the same side as the ball, so you could drive up to the hopper, right? Ben, you want to explain the rest of it?
Yes. So you will be able to feed from the same side as the hopper and then immediately drive the gear-facing side towards the lift, while also being able to shoot at the target, hopefully while moving, if we do that well. And so effectively, you would be wasting as little time as possible in your whole receive game piece and then remove game piece sort of cycles. And last year, at least in previous years, the amount of time that you can spend on those cycles was really dependent on how much you would score. If you can get those cycles as quick as possible, you would probably have one of the better scoring robots.
So, for the shooters, the fuel essentially is going to be going down by gravity. So, again, that chamber is going to have a slope which is going to bring
Can we
it
turn the
down.
light back on?
Yeah. Okay. Anyways, so it'll go down. High school, I know. Anyways, so we're going to have a 6-inch wheel, and we're going to have a backing bonnet, almost like a hood, if you will, which is going to, the one goal was we wanted to be able to adjust the angle which it is shooting, but another thing we were worried about is making sure that there's as much contact time between the wheel and the ball, so we can get the greatest efficiency out of shooting, most power, etc. It's mounted on a Lazy Susan, which allows for, let's say, around 180 degrees of rotation. If we want to get ambitious, 360. Because again, we want to be able to shoot while moving, so if we're going in one direction, we need to have this on the back, just firing away like a turret. Fuel fed through a hole in the center, and again, plus or minus 180 degree aiming range.
Yeah, so effectively what that means is if I'm a robot, this is my turret, I can turn all the way around or all the way around the other way. So effectively you get 360 degree range of movement from a static point, but it's plus or minus 80 from a single position. Or 180 from a single position. Yes, so this is a really rough design of sort of how a robot would look volume-wise. As we said earlier, we decided on the short configuration. So this sort of is meant to represent the shooter. That's also coincidentally an optical illusion. So
It's off.
Yes, this is basic base. We plan to approach the hopper with the short side, the 36-inch side, and the balls will be able to spill over the top and actually enter in order to be collected. So, pretty rough overview of what this is.
Excellent.
Top view. Oh, no,
This is
it's
the right
a side view.
Right, this is the side view from the right side. Same sort of deal. The reason there's a large box that's left entire space the volume. The shooter is the highest point on the robot.
We want to be able to move it up and down. We don't want to exceed the 24 height.
Yes.
24 height.
Right. Yes. So top. Okay, great. So yes, top view. Again, shooter, rest of the robot.
And then show blue.
Okay.
Okay, so we're going to have an X5 camera for shooting so that we can have a general view of where it is we are actually shooting. Hopefully we'll have some sort of auto itch aim system, but it's always good to be able to see. And we want to have USB cameras in the front and back because we need to be able to load our gears from the front. But on top of that, we also need to be able to see the balls that we are trying to, pick up from if we ever decide to use the ground intake. So we want to be able to see the balls coming and know when to drop so that we can do it.
As many people noted, visibility is exceptionally poor in this game, so having cameras is very important.
So where are you getting the third USB port from?
Alien technology.
We had
cameras last year.
One was an IP
Fine.
USB splitter.
IP camera, whatever.
Kicked it off.
USB splitter.
We don't care, we'll find
It
it.
doesn't work.
What he said.
That's it.
That's
it.
yes.
Woo. Yeah, any questions?
That is?
Any questions?
Yes.
Do you anticipate, since speed is an important element of this game,
Yes.
do you anticipate that your speed across the field will need to change if you're chasing balls, sweeping them up?
So the intent here is not to chase balls. The intent here is to have our intake running as we're driving across the field. So any balls that are activated by the hoppers, which are also...
I want to revise my question.
Okay.
As you're going across the field, from point A to point B, you will be attempting to traverse as well as collect.
Yes.
Do you need to adjust your speed to collect while traversing?
I shouldn't think so. It would be something we'd have to figure out through some prototyping, whether going too fast would affect our efficiency in intaking. But I don't anticipate it will cause much problems.
This is the answer to the subject.
Yes. Any other questions?
How are balls going to go from the hopper into the shooter?
Something like your design.
Have you accounted for the fact that you have to be able to get every single game piece out of your robot at the end of the game without turning it on? So if there's balls in your hopper, can you get into your hopper without turning the robot on?
Everybody has the same problem. So one side of the robot is going to have a pin. You just flip it down and all the balls come.
Oh, but but as far as I can tell, they have an enclosed robot. A lot of the other teams have.
That was just the volume parameters. We're not anticipating having the entire robot closed because then you can't get balls in from the
Yes, tank drive. Tank drive short configuration. And we'll be driving with the 36-inch base motor.
So you're not using the Nexus for docking with the loading station or with gears?
Well, I would hope you know, you would know because you're in our group. But we basically sort of listed out the cameras that we would need. We didn't necessarily assign all of them, but it would be very possible to use the Nexus camera for one of those things. Actually, there's one caveat, which is that we was planning to have the camera